Okay, today we are going to begin the study of geometry that is in Math 115, and we are going to start with a lot of definitions because we have to know what we're talking about. Geometry itself can be traced to the Greek mathematician named Euclid. He lived back in 325 to 270 BC, so that's before Christ was born. And he must have been an incredibly brilliant man, because the book Elements is a lot of stuff that Euclid figured out. And so it is I have a copy of the book, it's incredible. And it's a study of plane geometry, in other words, geometry on a flat surface. And so there's a lot of stuff in geometry. We're only going to begin to touch it in this geometry class. We're going to talk about the things, though, that are used the most. So this first video is just going to be lots and lots and lots of definitions, because you're going to have to use those definitions when you talk about the things in geometry. And so the first thing we're going to start with is a point. What is a point? A point is something I would just call a dot. That is an example of a point. But what is the definition of a point? It has no length, no width, and no width or shape. Okay, so that's what a point is. It has no length, no width, no breadth or height, and no shape. A dot is a real good representation of it. Okay, what is a line? A line, we usually draw something like this to indicate a line with two arrows on each end. And it is a collection of points that extends infinitely in opposite directions. And those arrows on the end of that line indicate that infinity about it, that it goes on and on and on and never stops in both directions, okay? Now, from this line, we have part of that line called a line segment. A line segment is a line with a beginning and an end. In other words, it looks like that. It stops. It has length. It has width. Not width. It has length. Okay? So, it is part of a line, but not the whole line. It consists of two endpoints because it has a beginning and an end. So, two end points are on a line segment. Whereas on the other hand, a ray is also part of a line, and it is often called a half line. And the reason it is called a half line is because a ray has one endpoint and no ending. And goes infinitely in one direction. And we often indicate this one with a dot to begin and an arrow on the other end, meaning it's going on infinitely. A plane, on the other hand, is a flat surface. It has no thickness, depth, or boundaries. We often use something like a piece of paper to represent a plane, but again, it's not completely accurate because a piece of paper has boundaries. A piece of paper has thickness, even though it's a very small amount of thickness. Okay? Now, how do we label a point? We put a dot and put a capital letter for a point. And we would call this point P. Okay? A line. We put 2 points on this line, and then we would call this line AB. Okay? And notice we use the arrows on either end to indicate that it is a line. Okay, how about a line segment? This is the point A and the point B, so we would call this line segment AB. You notice the difference when we actually draw the line segment. You have the name of each point under the point, but when we make line segment AB, you put your A and your B, one right after the other, and put a line segment symbol above it, okay? How about a ray for AB? There's my point to begin my ray. I'm going to call it A. I'll put another point on it for my B. And now I'm going to make my ray symbol, and underneath it write AB. And that gives me ray AB. Okay. A plane, on the other hand, is established by 3 points which are not on the same line. So let's erase so I can write that down. A plane is established by 3 points that are not on the same line. Okay, for example, if I have 3 points all on my same line, that only establishes a line. It doesn't make a plane. So to get to a plane, you can't have your points on the same line. I've got 2 on one line, I've got 2 on a line, and I've got 2 on a line. So none of those are on the same line, and that would establish your plane. And we usually draw a plane, something like this, and we'll label it. A capital letter would be the label of that plane. The shape can be any kind of a shape you want, and that would be a plane, and a capital letter on it labels your plane. Okay, now we're going to look at different kinds of lines. Okay, when 2 lines cross, this would be line 1 and line 2, two lines crossing, are called intersecting lines. When we have intersecting lines, there's a lot of information we can get from those intersecting lines, and we'll go into that in a bit. Two lines that run in exactly the same direction and look like what I call railroad tracks, these are called parallel lines. And they will never intersect. Parallel lines do not ever intersect at all. But these lines will be coplanar. These will be on the same plane. Okay, how about another kind of line? Intersecting lines that form 90-degree angles at their point of intersection. 90-degree angle. These lines are called perpendicular lines. Okay? Now, let's look at the parts of an angle. An angle is made up of two rays where the end point is the same for both rays. That is what an angle is. So, A, B, and C. So this angle is made up of ray AB or BA and ray BC. And the point that they have in common is called the vertex. And it is a common vertex. So now let's look at different kinds of angles. Okay. Okay, we would label this angle as angle A, B, C, or CBA. The vertex is between the points on the rays. So this angle would be called an acute angle. It is an acute angle because it is less than 90 degrees. This angle is an obtuse angle. This is an obtuse angle, and I'm going to use the angle symbol for both of them, because it is greater than 90 degrees. It is also less than 180 degrees. Okay? So it's between 90 and 180. This one is between 0 and 90. Now, a third angle with a 90 degrees on it is called a right angle. Just to shorten the word, a right angle. And in this case, angle ABC equals 90 degrees. So we have three kinds of angles that you see here, plus one more. We have an acute angle, we have an obtuse angle, and we have a right angle, and our last angle is called a straight angle. And a straight angle is nothing more than a straight line. Straight angle. And in a straight angle, the measure of angle ABC equals 180 degrees. So you see we have four kinds of angles that you're going to deal with in this course. Okay, so now we're going to look at other kinds of words that we use with angles. Okay, let's draw a picture here. C, D, and E. Okay. Adjacent angles. These angles are side by side. Therefore, they have a common ray. In this example, AEB is adjacent to BEC. So angle AEB is adjacent to angle BEC. Okay? They share the common side of EB, or the common ray of EB. So those are adjacent angles. Opposite angles. And another word for opposite angles is vertical angles. Okay, these share the vertex only. And are across from each other. Okay? In other words, angle AED is opposite of BEC. Okay, there's an example of it. Vertical angles equal each other, so therefore angle AED is also equal to angle BEC. Okay? Vertical angles, this one equals this one equals this one. Opposite angles are equal to each other. Now, the sum of all the angles in here of four angles is 360 degrees, because they form a circle if you think about it. and a circle has 360 degrees. We could also say angle AED is adjacent to DEC and opposite to BEC. So we can combine them together in various ways as well. Okay, so this leads us then to supplementary angles. If we look back at the picture we just had, supplementary angles are angles whose sum in other words, addition is 180 degrees. Better not go further. I'll run off the edge. Okay, so if we were to look at this picture over here, angle AEB is supplemental to BEC, and the sum of AEB and BEC is equal to 180 degrees. In other words, supplementary angles add to 180 degrees, which also forms a straight angle. Okay? Complementary angles are angles whose sum is 90 degrees. When we have two lines that are perpendicular to each other, we would write this as line 1, line 2. We could say line 1 is perpendicular to line 2. In other words, we use a symbol to indicate perpendicular lines. We could also say line 1, that's not very good, that's better. Line 2, line 1 is parallel, let's do it this way, to line 2. We use two parallel lines to indicate parallel. So those are things that we have with lines. And the last kind of a line is a skew line. And it's awful hard to draw skew lines on the board. If I had a line up here and I drew a line like this, that's about as best we can do in indicating a skew line. But what is an actual skew line? It would be as though I had a box and I had one line on this side of the box and another line on this side of the box. Those two lines will never intersect because they are in two different planes. So it's important to understand that skew lines are in two different planes and they never intersect. Write that down. Okay, I'm going to do it by drawing a cube here, or a box. Okay, here's one line on this side of the box, and I'm going to put another line on this side of the box. So their lines are on two different sides of the boxes, and because they're in two different planes, they cannot intersect. Okay.